as you may, if you've attended another webinar, you'll notice that this webinar is really focused on applications that we used Design X for that are just very good, compelling success stories, right? To show off what Design X is capable of. We show the basic demonstrations all the time. My job as an applications engineer affords me the ability to do demonstrations on customer data and demo models all the time. And I see a lot of amazing workflows that many people don't get to see on a day-to-day basis. So the focus of this webinar is to go ahead and show those types of stories that we've worked on over the many years. So with that, let's go ahead and get started with the medical one that I brought up here at first. And as usual, I always like to highlight the different devices because that's a key component here with these workflows is you have to have different devices to capture the information and deliver that to Design X. And there's a whole bunch of great scanners out there that I highlighted earlier. And the way I like to think about this is I often explain this to customers that are new to this industry is think about these devices like the consumer camera market. The consumer camera market has a whole host of different kinds of cameras, anything from a camera within your cell phone to full-fledged professional cameras that people use for photo shoots, or you have video cameras that specialize in video for watching sporting events, right? Or you have action cameras that people take out on the mountain when they go skiing or snowboarding. And that's the way the camera market for scanners is as well. There's a whole host of different kinds of technology packaged in different ways with different envelopes and different specialties. So that's why there are so many scanners out there, is there's no one scanner to handle all applications. Some of them have larger envelopes, higher accuracy, all different types of technology. So for this one, we utilize these types of scanners for this type of application. Now I'll just go to the next slide. This one used structured light. So the structured light scanners would be something along the lines of this one right here, where it's shining a fringe pattern on the shape of the part. And as that fringe pattern deflects, the camera can triangulate the rows and columns of pixels and assign depth values to each one. And that's just the gist of how that device works. But in this instance, the medical world has this piece of surgical equipment, this foot pedal, and we went ahead and scanned that. And as you can see, it has a lot of features to it. And we captured that information with a white light structured light scanner, and then brought it into Design X for modeling. So with that, I'll go ahead and switch over to Design X. So here is Design X. Here's the scan data. As you can see, it looks amazing, and there's a lot of features here. See, it's an elaborate model. So an accurate scanning device, also one thing to pay attention to when you're looking at scanning devices, ones that can scan these thin features and be able to maintain a good, accurate, thin feature representation of the model. So as you can see, here is the model. And as usual, the structure of this demonstration is not for me to use the software and do all the modeling, although sometimes as an AE, I can't resist actually showing some of the features and doing some of the modeling and things like that. But really, it's highlighting the fact that these are history-based models within the software, so I can actually roll back and look at the approach of how this model was created within inside of Design X. So you'll see over here on the left-hand side, I have my feature tree. And the first thing in the feature tree is the scan, a polygon object, and then a region group. And I'll just roll down just after that, and we will do a rollback. So those of you that have used history-based parametric CAD models, this is very similar technology, right? Where you have this history base and the features build upon each other. So if I roll back, and sometimes it takes it a second for it to recalculate Now you'll see that just after the region group, we'll just walk through the approach that was taken to model this part. And every one of these models that I've selected to highlight some neat features that are within inside of Design X, right? So let's go ahead and get rolling here. So if I roll forward, you'll see that the first step here is that we created a mesh sketch, which many of these models start with just your basic mesh sketch, which is the key functionality to this product here. And you'll see that if I go ahead and turn on my sketches here and highlight and turn that on, you'll see that we created that sketch, and then we'll just roll forward here and you'll see that we extruded it. So since this is a symmetrical part, you can see right away one key idea here, which is typical for 3D CAD modeling, is we're going to model half of it and mirror it across the center line there. So in this instance, you can see right away I can notice as I look at it, because I didn't model this one originally, but you'll notice this person decided to take a constructive approach where they're going to construct a main block and then slice and cut away, right? So that is a very distinct kind of modeling approach that you're going to notice here, and I'm just highlighting it as we roll forward. So now I'll just roll forward a few steps. There'll be a couple sketches, and then you'll notice a sweep after that. So we'll just let that calculate. And you see after it calculates, we'll take a look down here. We'll highlight this. So right here along this side. And if you're ever unsure, you can even edit this feature here too. So if I just come over here and edit, you'll see what the approach that they took. They created a profile sketch and swept it along a trajectory here, just like that. So really neat approach there where you've created a sweep. So there is the feature I can edit, but I can also come over to each one of these sketches. So this sketch right here, or this sketch right here, I can edit that and come in here, and you see that they went ahead and came in and sketched that, and they're going to chop it away. So if I hit OK, it chops it away. Now if I roll forward here again, we'll just give it a second to recalculate. And then we can see that here, where it went ahead and we chopped away from this direction using this sketch right there. Actually, this is an add. So they did you notice that the first block did not include this, and then when they added that to it to add material there. And then we'll just go forward a few more steps. And you'll see that we added some fillets and some draft to the outside there. So there we go. So we click on there, you see we added some draft and some fillets. And now we're just going to continue cutting away. So we'll just take a few more bigger steps forward here and just look at what we cut away, chop away from this direction over here, where you can see there's that lip there. So you can click on the fillet, click on the feature over here, and you see the different cut adds, and then you can click on the sketch, and you see that they went ahead and extruded that down. So now we'll just keep jumping forward a few more steps here. So now you'll notice that we did a few different things. We went ahead and did another sweep cut right here. And then you'll see that we did another extrude cut in this direction. So the sweep cut is right here. And it's using this profile and this profile. So it's following that. So we went ahead and took that profile and swept it along that trajectory right there. And then you'll see here, if we go forward, they did an extrude cut in this direction. So now if we go next, we'll just go to the next 2 steps forward here where we do a mesh fit and then a cut away from the surface there. So now if we go to mesh fit, and we can always turn that on and see that they did a mesh fit along the outside. And as always, I always point out here, this one was done with a mesh fit, but you could use the loft wizard as well. Those 2 tools are interchangeable. This one is going to give you a history to come back and make changes to the profiles. The other one is going to, the mesh fit just gives you what it gives you, right? And it does a best fit surface there, a nice organic shape to it. So go ahead and hide that surface there and jump forward a few more steps. So you'll notice that we did a chamfer, fillets, and some more extrude cuts. So once this finishes recalculating, you'll notice that the extrude cut is this pocket here, that they went ahead and cut that away as well. And we'll just zoom in here. So this profile sketch right here, cutting away. And in this chamfer, you see here, if I click on the surface to find the last feature that worked with that feature there, so that's a chamfer right here, and then that. So just cut forward a few more. And then it looks like we went ahead and did another cut here in the middle to cut through all the way. So you'll notice here, if I click on this, and then here is your sketch, which will highlight the sketch that we worked with there. Another mesh sketch, cutting it away. You notice everything, they're basically taking care of everything from the top side and adding all the features from that top side right now. And then we'll do some more fillets and a couple more extruded surfaces, which is really neat here. We'll just highlight this one. Surface there, surface here. And I'll turn those on so you can see them. And then we'll go forward a few more. It looks like we're going to do a kind of a complicated surface trim to each other. So we're going to take these guys and trim them all after we create some fillets and surfaces, and then we'll just jump to the trim here. So now we'll go ahead and turn that back on. So you see that we created that tool where we trimmed all of those pieces together in different stages. So you saw sometimes you trim this one, this one to that one, and then these 2 to that one, and you can do them in different stages. Sometimes you can get away with consolidating them down and doing less trims. Other times, sometimes it can be difficult to keep track of all of them at once, so it might be easier just to do them in stages. But now, after they created this tool, then you go ahead and say, hey, now I'm going to cut this away from the main solid body. So now, make sure to turn that off and this on. We cut that away by cutting this guy out. You see that? Just break it down into sections, right? So now we're working on this area. We cut that away. After we cut this, we cut that, this we rewind back. So now let's just go down a few more steps and roll forward and check out this next mesh fit that we have. All right, so now we have that mesh fit. We can go ahead and turn on the surfaces, hide this one, and see that we added this other guy. And it looks like we're going to fit some more extrudes. And then we'll go ahead, and I'll show the mesh here in a second. So there we go. We'll hide the solid, turn the mesh on, turn the surface on. So you can see where we're going here, where we're creating this surface here. And then we'll go ahead and roll forward and trim these together. And again, this is another one of these techniques where you're going to create a tool in some different stages to then use that tool to cut away from the main body. And this is why I like to call this type of workflow, like where we create a positive object and then go ahead and use all these tools to then cut away from it. So you see here that we did some more trims, cutting it back from different directions. And then I'll turn the solid on here in a second, so just to refresh where the solid's at versus where the mesh is, so you can see the approach here. So if I turn that solid, you see here, looks like we're gonna cut this all away here in one stage. So now we'll just come forward a few more fits and extruded surfaces and a few more trims. And then you'll see that master tool here in a second, because then we'll do a cut after the end of these stages. So I'll hide the mesh. There's where we're at so far. And here's where the solid is. So let's go down to the cut. All right. So we'll just turn that on. You'll see here. Turn that off. So there we are. We're getting there. And then we'll go ahead and cut this away. So as you can see, just bundling and putting a bunch of features together and creating a nice tool to work with, and then cutting it away from the solid. Now, turn on the mesh. You see there where we're at. And hide the mesh real quick to see where we're at. So now we'll just kind of zoom forward a few more, because now it's kind of rinse and repeat. Once you understand the concept of how to model this part, you're going to see it's the same steps, just cutting the pieces, mirroring, rolling back and trimming these tool entities from the main body and going from there. So you'll see here it's a lot of rinse and repeat. So we went ahead and mirrored, and then now we'll do a cut to cut that away. So let's just turn this off so you can see, because there are, like, the majority of the part is symmetrical, but then there are some varieties of differences. So once you get to a certain stage where you're going to add some of these distinct features, it makes sense to go ahead and mirror it now and add those distinct features. So you can see here, you got these guys here. And we'll add some details. By adding some fillets there. So you can see if I click on the fillet over here in the tree, like we've been doing this whole time, you can see it'll highlight where that was applied. So now we'll just jump forward. And we should be close to finishing this side. We'll see here in a second. And then we'll check out the next side, the opposite side there. Let's go ahead and do a little bit of cleanup here. Hide some of the sketches that I turned on before. So this is where we're at so far. And you'll notice that we did a shell. I went a little too far by clicking after all the fillets. But we did a shell of the opposite side here, and you can always click edit, and you can see here that we selected that face as the bottom when we did a 2.9 millimeter shell to it, and then hit OK, and it will actually recalculate it there. So now you see we have a nice beautiful shell. And then now the process goes that we're going to go ahead and add some of these features in. We're going to do some trim work on this and then add the standoffs to the backside here. So if I come over and drop down a few more layers. So now if I just click on some of these features here, see where they are. Oh, we went ahead and did a little bit of work on that opposite side there first before doing the other stuff on this side. Now you'll see that that cut was us removing and cutting away from that opposite side of the distinct feature that's not symmetrical on the other side. So you see that there. And then we'll just skip way down here. So you see there, we got the fillets all applied there. A lot of dress work here. Oh, we went ahead and added this here. If you click on that, and we're almost done. So I'll just roll to the end here. So now, let's roll to the end here. Lots of hole cutting and minor dress up features here. But we'll just click on some of these so you can see where they were in the tree. So if I just click back, that was part of the mirror. So maybe we're here. Extruded. Here's the sketch associated with it. And come back and add draft to it. But you see here, that is the complete model. So we'll go ahead and toggle on the mesh and see how much work was done. So I often get asked with Design X, you know, when you're showing the software and people model something very simple, you know, they ask, how much time does this save me? This saves you an exponential amount of time with a project like this, right? With this part, it would take quite a long time. I mean, it's thousands of measurements in the end that you would have to make by hand or some other way. Where this, I mean, you're able to model directly over top of it and then get feedback by applying this accuracy analyzer here and turning that on or off and modeling it. So you see here that it just saves an exponential amount of time, and it just depends on how many features, how much time that's going to save you. So for a large project like this, it's just a ton of time. Now, once you're done, you have that ability to live transfer over to a CAD package here, right? So when you send that over to a CAD package, it's going to send these features as native entities into that CAD